Hey guys, today I'm going to teach you how to add rational numbers. Remember, rational numbers are just integers, fractions, and decimals. So by the end of this lesson, you'll be able to use models and algorithms, which means just a set of rules, to add positive and negative integers, fractions, and decimals, so rational numbers. Go ahead and get out your binder, turn to the math section, and get ready to take some notes. So you may want to go ahead and get started by looking back at your notes for the intro to rational numbers section. So in the intro to rational numbers, we began by looking at how we learned in fourth grade or fifth grade how to add and subtract fractions and decimals. You might want to review that and then come back and look at this first question. It says, jot down the process for adding fractions and decimals. So just really quickly summarize, what does it mean to add fractions? What does it mean to add decimals? So take a second, go back and look, review that in the intro to rational numbers section, and then come back and jot that down. So this is what I wrote down for my quick summary of how to add fractions. When you have a fraction, you want to find their LCD, which stands for least common denominator. So remember, a least common denominator just says like a least common multiple. It just means what's the lowest number that they can both go into evenly. Then you add only the numerators and keep the denominators the same. So we kept remember they'd have the same pair of shoes on before we could match their outfits. And then we just add. And then this was our quick review of decimals. We lined up the decimals, we inserted placeholders if need be, and then we just added like normal. So the same steps apply to adding various types of rational numbers. We will follow the exact same steps, we'll follow the same rules to add these rational numbers like we did with integers. For example, let's look at this adding integer sections. If the signs are the same, add and use the same signs. This is our first rule of the algorithm. We add like normal and just keep the same sign. So 7 plus 6 is like normal. We can count our fingers, use a tally, or just recognize that that's 13. You really shouldn't be using a calculator on this section. This should be a no calculator section. The next question says negative 8 plus negative 11. So the signs are the same, so we'll add like normal and just keep the same sign. So negative 19. You should do these along with me. If you need a pause, go ahead and try these, and then press play when you're ready to check. Do that. I want you to make sure that you get these. So let's go ahead and look at negative 3 plus negative 6. They're the same sign, so we're going to add and use the same sign. So 3 plus 6 is 9, and they are negative. This is like owing $3 and owing $6 more. So then let's look at negative 5 plus negative 14. I'm 5 feet underwater, and I go down 14 more. Now I'm 19 feet underwater still. And then the last one is an easy one. 12 plus 3 or 3 plus 12, either way you write it, is 15. So that was the first thing we did when we added integers. This is just review. The next thing we did is added signs that were different. So if the signs are different, we subtracted. When the signs were different, we subtracted. And then take the sign of the number with the greatest absolute value. So which is bigger, the negative number or the positive number? If we're just looking at the value of the number, the absolute value. So let's look at the first one. It says negative 2 plus 10. So they're different. So I'm going to subtract 10 minus 2, which is 8. And then I'm going to look at each number. There's more positive numbers than negatives. If I was looking at counters, I would have more positive counters than negative counters. So my answer, or my sum, would be positive. Let's look at the next one. 8 plus negative 17. So the signs are different. So I'm going to subtract and then take the sign of the number with the greatest absolute value. So they're different, so I'm going to subtract. So 17 minus 8 is 9. And there's more negative numbers than positive numbers. If these were counters, I would have more negatives than positives. So this would be a negative 9. Go ahead and try the next three by yourself and then press play when you're ready to check. I'm going to go ahead and look at 9 plus negative 7. When you see a plus negative, you should realize by now this is the same thing as subtract. So 9 plus negative 7 is the same thing as 9 minus 7, which is 2. I know that my sign is going to be positive because there's more 9 positives than the 7 negatives. Let's look at the next one. Negative 11 plus 3. So I owe you $11 and I give you 3 of it back. I still owe you, so it's still going to be negative, and it's 11 minus 3, which is 8. So let's look at the next one. If the signs are different, I'm just following my algorithm. They are different, so I'm going to subtract 15 minus 9, which is 6. And then it says take the sign of the number with the greatest absolute value. So remember, absolute value is just the bars. Absolute value of negative 15 is 15. The absolute value of 9 is 9. 15 is greater than 9. So I know that this will be negative since 15 had the negative next to it. So I'll give you a second to look at this page and just realize everything on this so far has been review. we've added fractions through this process, we've added decimals through this process, and now we've learned how to add integers whenever their signs were the same or different. But all of this on this page we should be pretty comfortable with and should be getting better at. We're still learning it, but we should be getting better at it now. So all we're going to do today is just extend what we know about adding integers into adding decimals. So if the signs are the same, we will add and use the same sign. So if you notice, it's the exact same process. So when I have 4.5 plus 6.3, I'm going to go up and just look at how do I add decimals. Line up the decimals first, insert placeholders if needed, and then add like normal. And if the signs are the same, I'm just going to add and then use the same sign. So I'm not going to do it in this space. I might want to move to a separate sheet of paper or a whiteboard, and I want to go ahead and write down 4.5, not horizontally, but vertically with that 6.3. And then I want to add like normal. So I go 5 plus 3 is 8. The decimals are lined up, and 4 plus 6 is 10. So my sum is 10.8, and since both were positive, my answer will remain positive. The next question has you adding two negatives, but it's going to be the same exact process. So we'll start by, since we're adding decimals, lining them up vertically. So we'll go ahead and rewrite this as 1.8 and 1.6. We're going to add like normal. Even though they're both negative, I'm just going to add like normal. So for now, I'm not going to write their negatives. I will come back and look at it and remember that they're both negative at the end. But for now, I'm not going to write the negative. So 8 plus 6 is 14. So I carry the 1. The decimals are lined up, so my decimals are in the same spot. And then 1 plus 1 plus 1 is 3. So my answer would be 3.4 or 3.40. And then I just want to look back at the problem and make sure that I recognize that if the signs are the same, I add, but I have to remember to use the same sign. So since I added them like normal, they're both negative, my answer will also be negative. So I know I got 3.4, and it would be a negative 3.4. Let's look at the next one the same way. And at this point, guys, I've done two examples with you, so now you should start trying these by yourself and then pressing play when you're ready to check your answers. We're going to do negative 3.7 plus negative 6.5. If the signs are the same, which they are, we will add and use the same sign. So I'm going to add decimals. I line them up vertically along their decimal. So 3.7 plus 6.5. I know that they're both negative. I can write negatives next to them if I want to, just to make sure that I know. I know that 7 plus 5 is 12. I know 6 plus 3 is 9, plus 1 is 10. So I get 10.2, and I know they're both negative. So I'm going to keep the sign and get negative 10.2. So I'm just using the algorithm right now. This is the algorithm. But I could also think about this like real life. I could spend $15.60 and spend $14, and that could be a real world example to connect to. So if you aren't sure whether your answer should be positive or negative, it might be helpful to think about this in a real world context. So let's go ahead and look at this problem. I know that they are lined up vertically along the decimal. I know they're both negative. I know that since they're both the same sign, I'm going to add like normal. So 6 plus 0 is 6. The decimal gets brought down. 5 plus 4 is 9, and 1 plus 1 is 2. And since they were both negatives, I'm going to keep that sign. So it's going to be negative 29.6 or negative 29.60. I see some people put. That's okay because there's zeros after these as well. So no matter what you do, you'll still get this answer. So negative 29.6. And then the last one is all positive. So your answer will be positive 3.3 plus 12.8. And let's pay attention with how we line this up. So 3.3 plus 12.8. The ones places should line up. 3 and 2 are in the ones places. And remember, there's an imaginary 0 here. If you wanted to write it like this, you could. I always feel ugly about adding up like that. I feel weird whenever I put a bigger number on the bottom. So I'm going to put 12.8 on the top, and then I'm going to put 3.3 right here. That just makes more sense to me, but you'll get the same answer regardless. So just going to show you both ways. I'll do my way first with the bigger number on top. 8 plus 3 is 11, so I carry my 1. 3 plus 2 is 5, plus 1 is 6, and then 1, so 16.1. You will get the same sum this way. 8 plus 3 is 11. Bring the decimal down. This is 6, and then 1. So you'll get the same answer, but like I said, I always like to put the bigger number on top. So we're just following the same rules for adding integers and applying them to adding rational numbers, and in this case, that's decimals. It says if the signs are different, then we're going to subtract, just like we did with the other one. So that's just like we did with integers. And then take the sign of the number with the greatest absolute value. So exactly like we did with integers. So we are going to subtract on all of these because they have different signs. So a negative plus a positive means that we're going to subtract. So like I was saying a second ago, I write the bigger number on the top for addition because you have to do this for subtraction. So the bigger number is 10.7 as the greater value, and then you're going to subtract 2.5. So I line them up like this along the decimal. I take 7 minus 5, which is 2, bring down that decimal. I borrow to make this 10, and I get 8.2. So now I'm going to look back at the problem. I know I got 8.2, but I want to follow this last step. So if the signs are different, which they were, we subtracted, so we've gotten that far. Now it says take the sign of the number with the greatest absolute value. So the bigger value in this case is this positive 10.7. So the answer will be positive 8.2. So let's look at the next example. You have a positive 8.2 plus a negative 17.6. So we'll go ahead, since the signs are different, we're going to subtract. For now, I'm going to leave the negative out of it, and I'm just going to subtract like normal. I put the bigger absolute value number on the top, subtracting the littler number on the bottom. 6 minus 2 is 4. Bring down the decimal. Borrow, because I can't take 8 from 7. So I can take 8 from 17, and that is 9. So 9.4 is my answer. So I've got 9.4 I want to write down. And I know that I need to follow this last step, which is take the sign of the number with the greatest absolute value. So which absolute value is bigger, the 17.6 or 8.2? Since the 17.6 is bigger and it's negative, my answer will be negative. There's more negatives than positives. Let's look at the next one, 9.0 plus negative 7.4. The signs are different, so I'm going to subtract. And since the 9.0 is bigger than the 7.4, I'm going to take the 7.4 away from 9, and I'm going to ignore the signs for now. So to take 4 from 0, I need to borrow. So I'm going to borrow from the 9. So 10 minus 4 is 6. Bring down the decimal. 8 minus 7 is 1. So I got 1.6 as my answer. Looking back at my problem, I need to compare the positive and the negative. I know that there's more positives than negatives, so my answer will stay positive, 1.6. Let's look at the next one. Negative 11.8 plus 3.3. If you haven't already, please try this one and the next one by yourself, and then follow along with me. So pause now to do those, and then press play whenever you need to check. So for now, I'm going to go ahead and ignore the negative, and I'm just going to take 11.8 minus 3.3. Since the signs were different, I'm going to subtract. 8 minus 3 is 5. Bring down the decimal. Can't take from 3 from 1, so I have to borrow. I can take 3 from 11, and I get 8. So I get 8.5. Whenever I look back at my two numbers that I did my operations with, these two rational numbers, these two decimal numbers, there's more of the negative than there is positive. 11.8 is bigger than 3.3. So my answer will be negative. And then the last one in this section, again, please do this by yourself if you haven't done it already. I really want to see that you can do this and then check along with me. So negative 15.7 plus 9.2. The signs were different, so I'm going to subtract, and I start by subtracting decimals by lining them up vertically and then lining up by their decimal. So 7 minus 2 is 5. Bring down that decimal. Can't take 9 from 5, so I borrow. I can take 9 from 15, and I get 6. So I have 6.5. So then I look back, and I want to see which one has the bigger value, the biggest absolute value, and I know that 15.7 is the bigger number, just looking at the numbers, not their signs. But since it has a negative, I know it's going to be a negative 6.5. So decimals are one type of rational number. Fractions are the other. So the process for fractions is the same. It just requires a couple more steps. So we're going to start with like denominators. We're going to add fractions with like denominators first. If the signs are the same, add and use the same sign. You should start noticing a pattern here. This is just the same rule that you're going to keep following no matter what. So the process for adding fractions, looking at this first example, is to make sure they have a common denominator. They already do. 5 is the same as a 5. So I keep the denominator and I add what's on top. So 3 plus 4 is 7, and I keep the 5 on the bottom. This is an example of an improper fraction because the numerator, or the top, is greater than the denominator, so we call this an improper fraction. This is counted as correct in a lot of places, but it's not the most correct. So you can keep this for right now, but as you start to get better at these, I want you to realize that 7/5 is improper, and we write improper fractions as mixed numbers. So when we do that, we think, can 5 go into 7? Yes, it goes in one time with 2 left over out of the 5. So 7/5 is the same thing as 1 and 2/5. So you can write it either way and be counted as correct. And I'm going to rewrite that so it's more pretty. So those are your options for that one. Let's look at this next example. You have negative 5/6 plus negative 5/6. One big mistake I see people make a lot of the time is that they'll just put 0, but these are not opposites. Look at your rule. If the signs are the same, which they are, negative and negative, add and then use the same sign. So for now, I'm just going to ignore the negative and just do 5 plus 5, which is 10, and then keep the denominator 6. Since they were both negative signs, I'm going to keep the sign, so this will be negative 10/6. One important thing to notice here for negative 10/6 is that I could write it like this, or I could write it like this, or I could write it with the negative on the outside of the whole thing. So as long as you have the negative on one part of this fraction, it will be counted correct. I just wanted to go ahead and let you know that right now. We'll get into why next week, but this is probably what most people would write, or this is what people would write. But you really, you don't want to write negative 10 over negative 6 because that is not correct. It's only one place for the negative. So this is probably what I would write, or this is what I would write. This is still correct, but those are just the answers that I would probably write myself. And then the other thing that we want to do when we see a number like this is realize that it's an improper fraction because the numerator is greater than the denominator. So I can rewrite it as a mixed number by thinking, can the denominator go into the numerator? It can. It goes in one time, one whole time. 6 goes into 10 one time, and then there's 4 left over. So 4/6. If you're really with it, you'll realize that this is another number that can be simplified even further. 4/6 can be simplified or reduced because 4/6 is the same thing as 2/3. Both those numbers can be divided by 2. So make sure you don't forget your negative. This is the correct answer. This is the correct answer. I would count any of these answers on this page correct, but which one's the most correct? This one. So if you want to be really, really perfect and really good, you want to simplify it completely. You want to make sure that everything is written as a mixed number. So this would be the most correct answer. Let's go ahead and look at the next one on a separate sheet of paper on your little whiteboard because we want to make sure that we have enough room to solve one like this out. It's the same process. The signs are the same. They're both negative. So I'm going to add like normal, and then I'm just going to keep the same sign at the end. So let's go ahead and just add 3/4 and 1 3/4. There's a couple ways you can do this. One way might be just to realize you have the same denominators, so you can just add like normal. But what I do, and this is just one extra step, but it will make your life so much easier as we get harder problems, is to go ahead and I don't ever add fractions with mixed numbers. I only add fractions with fractions. So I want to convert this mixed number to be an improper fraction. So to do that, I always go like around the world. I draw my little arrows. I multiply 4 times 1, and I add what's on top. So 4 times 1 is 4, plus 3 is 7. So 1 3/4 is the same thing as 7 over, keep the number on the bottom. So 1 3/4 is the same thing as 7/4. Then I just want to rewrite my expression. 3/4 plus 7/4. They have the same denominator now for sure. And now I can just add along the top, which makes it 10/4 because I keep what's on the bottom. And then I simplify. 4 goes into 10 2 times completely. So 4, 8, 12. So 4 goes in 2 times with 2 left over out of 4. So I can simplify this one step further. 2/4 is the same thing as 1/2. So I might want to write this as 2.5 to be the most correct. This is correct and this is correct, but this one is the most correct. So make sure that you know that. Make sure if you haven't already, go ahead and try these next two. I know that they're fractions. I know we have a harder time with fractions. We don't like them, but it's just the same process. So please go ahead and try those by yourself and then pause, press play to check. So we're going to ignore the signs for now and just add these numbers like normal. 10 and 10 are the denominators. So since they match, I can go ahead and just add the numerator. 9 plus 3 is 12. And I just keep the denominator the same. So I get 12/10. I know that 10 goes into 12 one whole time. And there are 2 out of 10 remaining. So this was correct as an improper fraction. This is correct as a mixed number. But if you look, it can be simplified or reduced because 2/10, 2 goes into both of those numbers. So 2 goes into 2 one time, and 2 goes into 10 5 times. So 1 and 1/5, is the most correct. I'm not completely done yet though, because when I looked at this, they have both had negative signs. So all of these should also be negative. So my final answer would be -1 1/5. All right, so let's look at the last example in this section. 2 3/8 plus 1 1/8. So I showed you that I want you to make these improper fractions to simplify them or to combine them. But one other thing that you can do, if it works out like this, is to realize that these have the same denominator and you have two whole numbers. So you can go ahead and just add 2 and 3, which is 3, and 3 plus 1 is 4 out of the 8. You can simplify 4/8 to be 1/2, and this would be your most correct answer. But that was just a quick way to do it. You could also make them improper fractions and do it that way. It just depends on what it looks like. I like to make them improper, but when it's ones like this where you can just look at it and tell, you might just want to go ahead and add like normal. And since they're all positive, it's just going to stay positive, 3 and 1/2. So I know this is a long one, but we're getting close to being done. So this next section, if the signs are different, then subtract and take the sign of the number with the greatest absolute value. It's the same process that we did with decimals and we did with integers. So I'm going to let you practice these 5 problems on your own, and this will be the first thing we look at when we have class. And then I want to go ahead and look at the next section. So you can pause and try these now, or you can go ahead and just look at the next section with me. These 4 problems will be the last 4 problems that you try by yourself, and then these will be the next 4 problems that we go over in class. So it says find a common denominator. These are whenever you're adding fractions with unlike denominators. So there's a rule for that. It says find a common denominator. Then follow the steps for adding fractions with like denominators. So these are just your challenge problems because there's one extra step. They don't have common denominators. So you'll find the common denominator first, then you'll follow the steps for adding fractions with like denominators or the same denominators. If you need to, you can summarize today's lesson with a couple notes at the bottom and then try these all by yourself. All right, guys, that's it. If you made it to the end of this video, please comment, what did you do for your last birthday in the chat? Today we went over adding rational numbers. So now you should be able to use models and algorithms to add positive and negative integers and now also fractions and decimals. So now go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.